Hello and welcome back to my channel. In today's video I am going to show you how to build a function generator and using LTspice, which is a powerful circuit simulator software. As a student of electric engineering, you must have come across the need for a reliable function generator. So let's dive in and build one from scratch. First of all, components required. To build our function generator, we will need a few components such as operated amplifier, op-amp, and resistor, capacitors, and potentiometer. These components are easily available at any electronics store or online. Once you have all the required components, let's move on to the next step, designing the schematic in LTspice. Starting by opening LTspice and create a new schematic. The first component we will add is the operated amplifier, op-amp. In my case, I'm using TL072 module, which is a widely used operated amplifier. We will also add two resistors and a capacitor to the circuit. One resistor and capacitor will be used to set the frequency of the output signal, while the other resistor will be used to set the amplitude. Next, we will add a potentiometer to the circuit, which will act as a variable resistor. We will use the potentiometer to adjust the output frequency and amplitude of the signal. Once all components are added, we will connect them together as shown in the schematic. Then, simulating the function generator that we have designed the schematic in LTspice. Let's simulate the function generator to see how it performs. To do this, I will run a transient analyze and observe the waveform of the output signal. We will adjust the potentiometer and observe how it affects the amplitude and frequency of the output signal. Starting by adjust the potentiometer to 100k ohm, as you can see. Then simulate the circuit at 5 milliseconds. First square wave, then triangle wave, and finally sine wave. Going to connecting part. Now that we have designed and simulated the function generator in LTspice, let's connect it in a breadboard to see how it's performed in the real world. We will start by gathering the components we need and laying them out on the breadboard as the schematic. Next, we will connect the power supply to breadboard and make sure that the voltage levels are within the operated range of the component. We will then connect the output of the function generator to oscilloscope and observe the waveform of the output signal. We will adjust the potentiometer and observe how it affects the amplitude and frequency of the output signal. Finally, connect the circuit to power source, then check the output signal using oscilloscope. If you want to make more permanent version of your function generator, you can solder the component in a printed circuit board (PCB). This will make your circuit more reliable and less prone to lose connection. To do this, you will need to transfer your breadboard design into PCB. Next, you will need to solder the component into the PCB, starting by placing the component onto the board and using soldering iron to attach them to the board. Be careful not to overheat the component and to ensure that the solder connections are strong and secure. Once all the components are soldered into the PCB, you can test the function generator, starting with a square wave. As you can see, it's worked as I expected. Changing the potentiometer. Great, the frequency is changing. Going to next one, triangle wave connected to oscilloscope. Nice, the triangle is showing as I expected. Change the potentiometer. Also the frequency is changing as same as square wave. Last wave, sine one connected to oscilloscope. It's the same but with little noise. Also the frequency is changing. Awesome. In conclusion, that's how you can solder your function generator into a PCB from a more permanent and reliable circuit design. Soldering can be a tricky process, so make sure you are practice and follow safety precaution. It's important to know that the function generator we built in this video is intended for educational purpose only. While it may perform similar to commercial one, but it's not intended to replace them. So that's an important point to keep in mind while building your own function generator. Remember, this is an education project that's intended to enhance your learning experience in circuit design. I hope you found this video helpful. If you have any question or comment, please leave them in the comment below. Thank you for watching.